Hi apes, today we're taking a look at Unit 6 Part 5 and we'll start to talk about renewable energy. Today we'll talk about solar energy, wind energy, and biomass. Now before we start talking about the specifics of types of renewable energy, one really thing to consider is that one of the first steps we need to do is improve efficiency of the systems that we have. We do need to work on conserving energy and making sure we're not wasting energy. Now one big way we can do this is in transportation. The technology is there. We do have hybrids, we have cars that get 30 miles per the gallon, but not every car does. And so improving our energy efficiency in transportation is going to be a big step in conserving oil. Now in our housing, there's lots of steps that we can take. You can insulate, you can seal up your windows, make sure they don't have any leaks, get double, triple pane windows. There's improvements we can make in water heating. That actually takes a lot of energy to heat water in those big standing water heater tanks. We do have tankless water heaters that are a little box that gives you hot water on demand. We've made huge improvements in lighting. It used to be that all the light bulbs were incandescent light bulbs, the ones that get really, really hot. And when it gets really hot, what that's telling you is that most of the energy coming into that light bulb is going into heat rather than light. And so we've changed that and now have LED and compact fluorescent light bulbs for lighting mostly. We're going to go over different ways of doing passive solar energy, designing your house or using materials in your house that will take advantage of just the light and energy from the sun. And then also appliances. I'm sure most of you guys have Energy Star appliances in your house now. And when you get that Energy Star appliance, what that means is it has up-to-date technology that helps to reduce the energy required to run that. And then finally, what we need to take a look at is how does economics come into play in this? Taxes and subsidies are economic strategies that allow you to encourage people to do something. So if you tax something, that's going to discourage them from using that because it makes it more expensive. If you subsidize something, that's going to make it cheaper and that's going to encourage that use. So currently what we have subsidized is oil and fossil fuels. And so what that means is that gas and oil and natural gas are artificially cheaper than they should be because the government helps to lower that purchase price with subsidies. And so that is encouraging the continued use of fossil fuels. Whereas some other countries will actually tax their fossil fuels, and that makes them more expensive, and that discourages their use. So you need to tax the behaviors that you don't want to occur, and subsidize the behaviors that you do, and that's going to help you to encourage people to do something using economics. Now with solar energy, we're going to be taking a look at both passive and active solar energy. Now with passive solar energy, what's that using is just the light of the sun. There is no conversion to electricity. So a lot of times with this, you're going to see different designs on your house. So one way that you can do this is with an overhang. So when you have a house with an overhang, what that means is it's going to create shade in the summertime. So when the sun angle is really high, that sun angle will hit that overhang and it will create shade. Say, think of a front porch. But in the wintertime, when the sun angle's lower, it will be able to go underneath that overhang and heat your house. Now, let's say that you have something in your floor that can absorb that light energy and radiate heat. There are materials, there's tiles that you can do that can absorb light energy and radiate heat into your house. Another common thing that people might do is actually have trees planted here as well, so that in the summertime, sunlight will be blocked by the tree, and in the wintertime when it loses its leaves, the sunlight can go right through. Another thing you can consider is the color of your house. If you're in a cold climate, you want to absorb energy from the sun, so you might paint your roof a dark color. But if you're in a warm climate and you don't want that energy from the sun, you might have your roof, say, a white color so that you can reflect sunlight and use that for cooling. Now another thing that you might have is insulation in here. You might have different kinds of colors to absorb or reflect sunlight. Another big thing that you can do is you can have heated bags on your roof that are of a dark color that will absorb the energy of the sun, heat water, and then you can have hot water that's heated from the sun. So these are just some designs that you can do that will take advantage of the light of the sun, not converting it to electricity. But probably what you think of more when you think of solar power is what we refer to as active solar power. So active solar power does convert to electricity. Now, one of the most common ways we do it is with a photovoltaic cell, which is made out of 2 layers of silicon. And it's got a conductor underneath it. So think of it as like a sandwich of silicon. So what happens is when sunlight hits the top layer, it excites an electron that forces it through a circuit to the bottom one. Now, essentially what electricity is it's a flow of electrons. And so if you can excite the electrons on the top, it's excluded from this conductor down here, and you create that flow of electrons, and that's your electricity. Now, the thing with solar power, though, with these photovoltaic cells, is that you don't get a tremendous amount of electricity from each individual cell, so you do have to line them up in a series. Now, also for large-scale solar power, we have what's called a solar power tower. So these would be like those fields of mirrors you might have seen. So the field of mirrors, the goal there is they will track the sun, and they will angle the sun up to the receiver. So you're angling the mirrors to concentrate the light of the sun, and within that receiver there's going to be a liquid that's going to absorb that heat. We can pressurize that liquid to make steam, to turn a turbine, connect it to a generator to make electricity. And then you come through, you condense that water, and pump it back up to be heated again. So this is making electricity in our traditional way that we did for coal, oil, nuclear power, but using the energy of the sun as that mechanism to heat the water. So this would be a large-scale type of solar power. Now, for us in the United States, solar power doesn't work everywhere. So you're going to see those solar powers or solar towers down here in our southwestern quadrant. But what this graphic shows us is that solar power just isn't feasible everywhere. It's very manageable in the red area. It's marginal in the oranges and yellows, but once you get into the greens and the blues, it's just not a reliable enough source of energy. You do need to have a powerful sunlight to make it something that is a feasible source of energy for you. So for us in the United States, it's not an everywhere solution. So our advantage of solar power is that it is unlimited. It is what's considered to be a perpetual resource because we won't run out of the sun. And there's no direct air or water pollution. And this is important here when I say the direct, because the creation of photovoltaic cells, the building of solar power towers, those do have some impacts. But the use of it has no CO2, no SO2, no particulate matter, when you use that solar power, okay? But the use of it does, or the building of these materials does. So the disadvantage is sometimes it's not cost effective. You do need a lot of solar panels to make it work, say on a house. You do need storage and backup because every day nighttime happens. And what we use here typically is battery storage. If you're using this for household use, you're going to need a battery. And those batteries can have toxic waste that might leak out. They need to be replaced and disposed of. So you do need storage and backup. It is very site specific, like we saw on that map. Not everywhere has enough solar power. And the processing of the photovoltaic cells causes problems because you do have to mine the silicon. So you do have the environmental impacts of mining, and silicon is a non-renewable resource, so you will potentially run out of that at some point. Now, biomass is another type of energy source. Now, biomass, what this really stands for is amount of living things. So this is a weight of living things. So that's where we get that from. Now, traditionally, what we think of here is plant material. Biomass is actually one of the most commonly used energy sources around the world because people burn wood. So this is considered to be a biomass energy source when you burn trees and wood to heat your house or cook your food. Now, the thing about burning wood is that it does release CO2. But if you remember from our carbon cycle, we talked about the difference between old carbon and new carbon. That with the CO2 that's released from fossil fuels, that's what we consider to be old carbon. Whereas new carbon the trees that we burn has just recently absorbed that CO2 from the atmosphere. So it's part of that checks and balances. So while it still does release CO2, it is considered to be part of that new carbon cycle. Another thing that could be used for biomass is animal waste. You can burn poo. From what I hear, it doesn't smell that bad, but I've actually never tried it. Also, another thing that is growing in popularity are biofuels. Brazil does a tremendous amount with biofuels and making ethanol from sugarcane because their biome supports sugarcane growth. For us here in the United States, we use corn typically to make our ethanol-based fuels. So what we're seeing is that we're seeing a huge increase in the growth of corn because there's a lot of need for this flex fuel. When you buy this flex fuel for your car, it is run on different varying amounts of ethanol. So ethanol is an alcohol-based fuel that we get from corn. There's also biodiesel. So biodiesel is a little bit different from a biofuel, and that this is extracting oil directly from the plants, and then you're converting that into a biofuel. So things like soybean, palm is getting a lot of attention, that palm oil can be used as a biodiesel. So palm oil is causing a lot of problems in that it's leading to a tremendous amount of habitat destruction because of its tropical nature, and that you do need to create just one monoculture of palm to be able to harvest the amounts of biodiesel that we need. Another one that's starting to get some attention is algae because of the lack of land use that this doesn't need. You can have this done on water entirely, so you don't need to use the soils and the land. And then finally, this is actually where we get our energy from in Fairfax County, is landfills. When we fill our landfills with trash, we create an enclosed environment that decomposition happens very, very slowly and with very little oxygen. And one of the byproducts of that is actually methane. And if you can capture that methane escaping the landfill, you can use that as a natural gas. So we do consider garbage to be a biomass fuel source because it's made from living things. And that's actually how we get our energy. Now, the pros and cons of biomass: it is abundant and it should be renewable. It doesn't have to be renewable though, because we're seeing this with forests, that as we burn through the wood, you are creating a situation where you might run out of this wood service or this wood product. It can reduce waste products. For landfill trash, when you burn your trash, it reduces the volume by 90%. So when your trash gets picked up, we don't put ours in a landfill. We burn our trash. And so when we burn the trash to make heat, to heat water, to turn a turbine, to make electricity, what's created at the end is ash. And so the 10% of ash is actually what goes into our landfills rather than the trash. So there's actually two ways that landfills can be considered biomass. One is the methane produced, and then two, is the way that we make it, which is we burn our trash. Now, the disadvantages is it can result in air pollution, the CO2 from wood. So remember though, this is the new carbon, but also the biodiesel, the biofuel, that all creates carbon dioxide. Can also create carbon monoxide, NOx in particulate matter. So there are some air pollution concerns with burning of biomass. And it's not going to be as efficient as coal or oil. It does cost a lot. You do need a lot of this energy. So that's why not everywhere can burn their trash, but we in Fairfax County can, because we make a lot of trash. So you do need a lot to make this run. And when you switch to that ethanol in your fuel, it can reduce your gas mileage, so you might then need more. So there are some downsides to our biomass. And then our final one for today is wind. So wind power is another one of those perpetual types of solar energy. And essentially what wind is it's produced by differences in temperature. So air will be flowing based on differences in temperature. One big growth area for this are offshore wind farms. To be able to put wind farms right offshore of a beach, there's a lot of concern about this though for aesthetic degradation. Maybe some people don't like the looks of those wind farms. But I would say that of all of our renewable sources of energy, wind has the most potential for growth. So just to go over how this works. So you can see the design mini will have 3 blades and they're connected to a generator. So the pros of wind is that there's no air or water pollution. And again here, this is no direct air or water pollution because the construction of those wind turbines does create problems. And by that, again, when I say air or water pollution, I mean no CO2, no SO2, no SOx, no NOx, no particulate matter. Because it's never going to be enough just to say no air or water pollution. You have to be very specific in the types of air or water pollution that you're not creating. Now, in the general scheme of things, wind farms are relatively inexpensive because once they're built and installed, they are very low maintenance. But the disadvantages is very much like solar power. They are site specific. You do need a constant and significant amount of wind. So the biggest places that we see this are along coastlines, on the tops of mountains, areas that you think that are constantly windy. Another disadvantage is that a lot of people don't like the way they look, and there's a sound to them as well. There's like a constant humming. So some people think of that as aesthetic degradation or taking away from the beauty of the area. And then one final one is we're seeing that at times birds and bats can run into the blades and be killed. Now there are ways that you can do this, particularly for birds. They're seeing that if you just paint the blades different colors, and then birds can see that change in pattern, they won't run into those blades as often, and making sure that they're out of migration paths are another way that you can do this. But I do see wind as one of the biggest sources of energy that we have the room to grow in.